Oceans on Mars formed 300 million years earlier than first thought, according to a new study. Research suggests the planet's water systems appeared after a series of massive volcanic eruptions permanently altered the planet's surface around 4 billion years ago. The formation of Mars's oceans was linked to the violent rise of Tharsis, a 3,000-mile (5,000 kilometers) wide string of volcanoes that make up the solar system's largest volcanic system. Tharsis likely spewed gases into the atmosphere that created a global warming or greenhouse effect, which allowed liquid water to exist on the planet. Scroll down for video. Nearly a third of the surface of Mars was covered by oceans of liquid water early in the planet's geological history. But how they formed has largely remained a mystery. To explore how the planet's ancient shorelines changed over time, researchers at the University of California, Berkeley, examined images from early Mars orbiter missions. Previously, researchers believed Mars's oceans appeared long after Tharsis formed during a huge outpouring of lava from the planet's surface 3.7 billion years ago. But a new model proposes that the oceans formed at the same time or even hundreds of millions of years before the volcanic system sprung to life. After they appeared, these vast water systems evolved together, shaping the climate history of Mars. Researchers said. Study lead author and UC Berkeley scientist Dr. Michael Manger said the assumption was that Tharsis formed quickly and early, rather than gradually, and that the oceans came later. We're saying that the oceans predate and accompany the lava outpourings that made Tharsis. Volcanoes may be important in creating the conditions for Mars to be wet. Eruptions triggered by the volcanic system also created channels that allowed underground water to reach the surface and fill the northern plains, Dr. Manger said. Shoreline-like features seen on Mars hint that oceans may once have filled the red planet's northern lowlands. Dr. Manger told Mail Online the elevations of the shorelines vary by several kilometers over the lengths of the shorelines. This is unexpected because a shoreline should follow a constant line of elevation or sea level. We were looking for an explanation on what could have deformed the shorelines since their formation. The team suggests that the oceans formed with a constant line of elevation but were later deformed by the appearance of Tharsis. Evidence of water on Mars dates back to the Mariner 9 mission, which arrived in 1971. It revealed clues of water erosion in riverbeds and canyons as well as weather fronts and fogs. Viking orbiters that followed caused a revolution in our ideas about water on Mars by showing how floods broke through dams and carved deep valleys. Mars is currently in the middle of an ice age, and before this study, scientists believed liquid water could not exist on its surface. In June 2013, Curiosity found powerful evidence that water good enough to drink once flowed on Mars. In September of the same year, the first scoop of soil analyzed by Curiosity revealed that fine materials on the surface of the planet contained 2% water by weight. Last month, scientists provided the best estimates for water on Mars, claiming it once had more liquid H2 than the Arctic Ocean, and the planet kept these oceans for more than 1.5 billion years. The findings suggest there was ample time and water for life on Mars to thrive. But over the last 3.7 billion years, the red planet has lost 87% of its water, leaving it barren and dry. The growing volcano would have depressed the land and deformed the shoreline over time, which could explain the irregular heights of some shorelines. Older shorelines, such as those created by the planet's Arabia Ocean, show these deformations, while bodies of water that formed after Tharsis, such as Deuteronolis, do not show these changes, the team said. Dr. Manger told Mail Online, loading from the formation of the Tharsis volcanoes changes the shape of the planet. So a shoreline that formed before a portion of the Tharsis volcanoes would be deformed by any subsequent loads from later growth. The present-day elevation changes of the shoreline suggest the younger Deuteronolis shoreline formed during the late stages of Tharsis, and the older Arabia shoreline formed before or during the early stages of Tharsis.